This is Official Nerd Business.
Hello nerd boys and girls, welcome back to our programming series. Today we will take a crack at Euler problem 22 using Python 3. As you can see, I've created my base file, which we can run either on its own with this piece of code or through our main py, where it will call this piece of code. Both will result in a call to attempt number 1, and attempt number 1 is still blank. Let's see what we need to do for attempt number 1 this time. Using names.txt, a text file containing over 5,000 first names. Begin by sorting it into alphabetical order, then working out the alphabetical value for each name, multiply this value by its alphabetical position in the list. For example, when the list is sorted into alphabetical order, we will find the name Colin, which is worth 3 for the C, plus 15 for the O, plus 12 for the L, plus 9 plus 14, reaching a height of 53. And it is the 938th name, so that this Colin would score 938 times 53, resulting in 49,000 something. What is the total of all the name scores in the file? Now this will be a very short video because we are working with Python. Maybe you'll remember from problem 13. We had a similar problem requiring us to read a file, and we made a resource handler for that, so we're going to import the resource handler here. And in attempt number 1 we are simply going to use this. Excuse me. Talking and typing is apparently very hard. I've saved the file referenced here. I've right clicked and saved it as o22.txt in my resources folder, and that's where our resource handler will find it, and it will read the entire contents into one string, and we will save that string as such. And if we take a look at the names file, you will see that it is a long string containing first names, quotes which don't count, and commas. So in order to get a list of names, we will need to split the data on commas, and then rework it a little bit to drop the quotes. And I'd like to do it like this. So we data split will generate a list containing strings with quotes but without the commas, because it used the comma to split the one string into a list of strings. And we're going to pick up each element in that list as n, and we will replace every quotation mark we find with, let's at least match the type of quotes. Python isn't very picky about which quotes to use when, but since we are looking for a double quote, I use single quotes to encapsulate the double quote here. And let's reuse the single quotes here then. It's only nice, and it generates a list containing the ends of which the quotes are taken out. Then we need to determine what we need to sort it, and we could do that by calling sorted. Now we could simply print names, and if we were to run this file, it doesn't work. Oh wait, I forgot to remove this one parameter here. Alright, so now we can see that we have the list of all the names, over 5,000 names apparently, and they are sorted. So Aaron, Abby, Abdul. If you take a look at the original list, it starts with Mary, then there's a Patricia and a Linda, and etc. So now we have the sorted names. So we've got that sorted. I'm sorry. Let's see now if we can create a function to get the score of a given name. How would that look? Well, we need to know if we get a C, it's worth 3, so A is worth 1 point, B is worth 2 points, etc. And we are going to test this using colon. So if we were to make a remark out of this and then simply print name score for our friend Colin here, we should get 53, right? That's the example given. So let's see here. Obviously, score starts out at 0. Then for each character in the name string. Now, Python has a function called ord, and it will return the position of the given character basically in the ASCII table. Now, if you're unfamiliar with the ASCII table, it is the encoding of all the basic 128 or extended 265 56 characters available on your keyboard. Now with the more recent developments in Unicode, that's kind of skewed, but basically if we were to give this any character, it will return the character value of that. Now for Colin, let's have a look at how something like that would look. I'm going to print both C and its ordinal, its position in the ASCII table. And likewise, by the way, let's have a look. So Colin is spelled out here, and the C is worth 67 and not 3, etc, etc, etc. In fact, if we were to take a look at, we had an error coming through. So if we take a look at that, we see that the A is worth 65. But we want 1, so if we subtract 64 out of everything here, we should be good. And likewise, we have a character function that does the opposite, so that takes an integer. Let's see, 65 for example. What's your... not the A. This does the opposite. So the ord function, we feed in a character and we get an integer back, and the char function does the opposite. We feed it an integer and we get the corresponding letter or character back. So if we were to run this, we would see error spelled out again. This none here is because we ask this to print whatever this returns, but we don't return anything yet. And then we do the print of character 65, which is this one. We get an A back again. Oh, and here's the scores, minus 64 then, so that's working as intended. Now we don't want to print it, but we want to add it to our score, so let's do that instead. Right, and we want to return the score. Now if we were to print colon again, right, we do get the 53, so that's nice. This seems to work as intended. This is only half of the problem. So now for name in names, let's first define two more variables here. We want a total score and we want a loop. In fact, let's do this slightly different. Let's not say for I in range length. This is why the range object, by the way, This specifically is why the range object is not inclusive. This is why if we were to say if we do this, we get the numbers 0, 1, etc. up to 9, but not including 10, right? This is precisely why this is done. So if we were to have a list and we take its length, we get 5,000 elements, right? The over 5,000. I'm not even sure how many, but let's say there are 5,000 names in the list. Now this loop will run from 0 up to 4999. And that means that we get every possible index into the array. That is precisely why range is not inclusive, why it starts at 0 and does not include the highest specified element. That's why we can do this. Total increments by I. Unfortunately, we do need to add a one, that's why I added the parentheses. Because at first loop this is 0, and here we do want the 0, but here we want that 0 to mean 1. The first name should have a value and should not be multiplied by 0. Now we don't want the name itself, but we want the name score. And this should set us right up, and now we can return the total. Now let's have a look. Awesome, that was super fast. It added up over 5,000 names. In fact, I want to see how fast it did it. So we are going to run main by. Problem 22, no input needed. It took us less than 1,000th of a second to get to the answer, which we can see here, and I am going to spoil it for you. If you enter this over at ProjectEuler, you will get the green check mark. Now, for my own curiosity, there are a number of ways in which you can do this. This part, the main loop, is pretty uneventful. I mean, we simply need to do this with our data to get the order right, and then we need to loop over it piece by piece. So that's fine. Or is it though? I am, however, interested in this bit because now we have there is a second way in which you could possibly do this, and I'm not sure if it's more efficient or not. But we could simply define an alphabet string consisting out of A, B, C, D, G, H, Z. And now we could do this, for instance. Now what this is going to do, this is going to loop through the entire name again, and it will take a certain character and look it up in this particular string to see what the position is, and then give us back that position. So I'm kind of interested to see if this would run any faster than the other way around. Name score 2. I'm first gonna test it, of course. I want to print name score 2 using colon again. This should be 53. And it's 48. I'm 5 short. Oh, wait a second, there's 5 characters in colon. And I'm 5 short, so I'm missing 1 each. Oh, that's because when I return A, it returns a 0, of course, and not a 1, because it is at the first element. So C in colon would return 2 and not 3, so we can easily fix that by adding a bogus character. and rerunning this will give us 53, right? So now I'm going to run the whole thing through main.py. Yeah, it's comparably quick. It's slightly slower. I think the ord function is actually quicker than looking things up in the. I'm gonna rerun it in fact. Yeah, I think it's namescore 1 is slightly faster than namescore 2, so the ord function does its job. Let's have a look at a second completely different approach though. I've just cooked up a little idea here. I'm reading in the data again, and I am still splitting it up at the commas to get names, and I'm still taking out the quotes in names, but I am generating a second list off of that where I already do the ordinal replace in the list itself. So I've tested this a little bit, and I get this list here that you can see where each character in the name, so this is supposed to spell Aaron, A-A-R-O-N, so I've already replaced all the actual letters with ordinals, so all I have to do now is basically this. Let's again this should work too. This is set up correctly, so let's remain and let's see if this is any faster. This is really just off the top of my head. It's even slightly slower again. So our first setup using attempt number 1, not attempt number 2, and using namescore number 1 and not namescore number 2 should be fastest. Yes. So as you can see, using Python, this challenge is really easy. Reading in files, look back at the resource handler if you want to, and note that this is just really plainly reading the entire file into one string, then using the split method here to get all of the separate elements, taking out, this is attempt number 2, excuse me, attempt number 1, taking out the quotes here to get a list of names, sorting it with just one simple keyword, and then running through that sorted list using the range, and having just one function, again using a built-in function from Python to get all the numerical values for that number. It's just really quick, it's really easy to do, and yeah, Python as a language really helps you with this sort of list processing, so that's very nice. That's problem 22. I hope you've enjoyed it. I'd like you to check out my GitHub too, where all my source code is stored, and I will see you again next time. Thanks for watching this video on Official Nerd Business. Don't forget to like and subscribe and click the bell icon. Did we discuss everything you wanted to hear, or did we miss anything? Any topics you want to hear in O&B? Leave your thoughts in the comments. See you next time.